This video we're going to continue with alkenes, but looking at a very special class of them and looking at fats and oils. So we've got two different types of molecules that we've already talked about. We just haven't used these words to describe them yet. We have saturated and unsaturated. So saturated molecules are ones that cannot hold any more hydrogen. So that means there's no way I can change the bonds around and add more hydrogen without making the molecule, breaking it into smaller pieces. Those are going to be our alkanes. For unsaturated molecules, there is room to hold more hydrogen, and these are going to come from our alkenes and our alkynes. So for example, if I have an alkene with the double bonds, I can remove a double bond. I'm not making my molecule any smaller, but if I get rid of that double bond, now both carbons have space for more hydrogens to make it an alkane. So saturated alkanes, no way to put more hydrogen in without breaking the molecule into smaller pieces. Unsaturated, there's either a double or triple bond, alkene or alkyne, that could be removed to add more hydrogens in. So saturated and unsaturated are terms you've probably heard before, and one way you've probably heard of them is with respect to fats and oils. So saturated fats are fats that have only carbon-carbon single bonds. Unsaturated fats are ones that have at least one or more carbon-carbon double bonds. So it aligns with the alkane being saturated, alkene being unsaturated. Saturated fats, no more room for hydrogen. Everything is carbon-carbon single bonds. Unsaturated fats, alkene, you've got a double bond, which means there could be room for more hydrogen. So if we think about what we know about saturated and unsaturated fats, saturated fats are usually the ones that are things like butter and lard. They typically come from animal products. Your unsaturated fats are oils like vegetable oil, canola oil, and all the others. These are usually from vegetable sources. So butter, lard, those are all solids at room temperature. And the oils are all liquids at room temperature. So does this make sense with the melting point order that we talked about earlier? It does. So we said that alkenes have a lower melting point and boiling point than the alkanes, which means the unsaturated have a lower melting point than the saturated. So if it has a lower melting point, it's more likely to already have melted and be a liquid at room temperature versus the saturated hydrocarbons. So here's some structures of fats and oils. So this molecule here, as well as the one down here, this really is a fat or oil molecule. It has what we call this backbone, where there's 3 carbons. There's also some oxygens in there. That's the red. And then there's these 3 carbon chains branching off of it. Same thing with this one on the bottom. We've got that backbone and then 3 branches coming off of it. So those bigger molecules are the fat and oil molecules. And all the different types of fats and oils are different based on what those 3 chains actually are. When we visualize these, just for the sake of space, we're going to look at a single branch or arm of it. These are more commonly called fatty acids. If we refer to them as fats or oils rather than fatty acids, don't let that confuse you, okay? So this top example, everything is single bonds down the chain. So this one is saturated. And in the full molecule, all 3 branches are saturated. So you can see how nicely they stack together. So that's going to make it a relatively high melting point. If we look at the bottom structure, We do have some double bonds in there. So that means this one is unsaturated. And notice now how there is some kinks in the structure depending on where those double bonds are. So they don't stack as well, so that makes the melting point lower. Here's another viewpoint over here on the left. Here's a double bond, and if we look at how things are oriented on the double bond, the carbons are on opposite side, so that's trans. And if we look at this double bond, the carbon groups are on the same side, making it cis. You've probably heard of trans fats. Chemically, these are simply fat molecules that have trans double bonds in them. They are harmful, or less healthy, I should say, for you than the cis version. Mostly because if you think about what the saturated structure looks like up here at the top and compare that to this unsaturated trans version, they look very similar and the body recognizes them in the same way. Saturated fats are not very good for you. Unsaturated is better. So the best option are these cis fats. Very different structure. Your body recognizes them as different than the saturated and the trans fats. So just a little bit of a review here. We have our saturated fats. Everything is carbon-carbon single bonds, and they are going to be solids at room temperature. That's what we typically call fats. Unsaturated fats have carbon-carbon double bonds, and those are typically liquids at room temperature, which normally we would refer to as oils. Here's a few more examples. If we look at this first structure, everything is carbon-carbon single bonds. So we call that saturated. The second example here, we do have a double bond. And if we check the orientation around that double bond, it is trans. So because there's a double bond, it is unsaturated. Another term that we can use is monounsaturated. Mono is the prefix for one. We learned that with naming before. So monounsaturated means there's one double bond. We can call it transunsaturated because that double bond is trans. We also label this as synthetic. So if we remember back a number of chapters ago now, synthetic means man-made. And our trans fats are all man-made. They come from either saturated fats or cis unsaturated fats. The last example here, we have another double bond. If we check orientation here, the carbons are on the same side, so it is cis. So it's double bond, we can call it unsaturated again. It's still monounsaturated because there's only one double bond. Now it's cis, and anytime it's cis double bond, those are from natural sources. So down here it is asking us to rank the melting points. So saturated is going to have the highest melting point because it's the alkane. The cis is going to be the lowest. And the trans will be in the middle. So same type of ranking as we did with alkenes and alkanes in the previous video. So I'd mentioned that the trans fats are synthetic, and if they're bad for us, we might be asking why we make them. So the trans fats come about when we do a process called hydrogenation. And the reason we do this is we want to make things like margarine or change the properties of our fat or oil. So we're starting off with a cis unsaturated fatty acid, and hydrogenation is a process where you add hydrogen. And if you're adding in hydrogen, earlier we talked about going between alkanes and alkenes. If you're going to add in hydrogen, you've got to lose the double bond. So in this case, we're adding in 2 atoms of hydrogen. So we lost one of the double bonds and we're left with only one. In this process, some of those double bonds can be switched into trans double bonds. And that's how we make the trans fatty acids. Nature makes the cis version, and then as we try to manipulate the properties to get specific type of fat and oil that we want, we end up creating the trans fats in that process.